Hello everyone. In this video, we're going to introduce how self-assembly happens in both macro and microscopic systems, and how different binding forces affect the self-assembly phenomenon. Self-assembly refers to the processes in which an organized structure is formed from a disordered system of components as a result of local interparticular interactions. This is achieved through constant dynamic rearrangement through attractive and repulsive forces until an equilibrium state of electric charges, magnetic properties, and shape tessellation is achieved. There are four main components involved in a self-assembly system: the driving force, structured particles, environment, and binding energy. In this example, the bottle caps are the structured particles in a water environment. A mechanical stirring driving force is applied, whilst capillary serves as a binding force. As the two neighbouring bottle caps float at the water's surface, a meniscus curvature forms around the bottle caps due to capillary effects. Thermodynamically driven, an attractive force is produced between the concave and convex menisci in order to minimize surface tension and retain liquid cohesion. This ultimately results in liquid repulsion by the solid. In this case, it is the concave menisci that attract the bottle caps together to hydrophobically repel the water in between and thus effectively binding the caps together. As surface tension is the driving force of capillarity, shape complementation becomes a secondary binding factor. As the liquid medium is driven to be repelled between the solid particles, this would be implicitly achieved by minimizing the total surface area exposed to the liquid. As a result, the solid particles are driven to tessellate, or be as close packed as possible to maximize capillarity. In the second experiment, the presence of a magnetic field served to create temporary domain alignments within the magnetic dipoles, providing additional attractive forces between the bottle caps. As can be seen in the video, this effect produces a much stronger binding force than capillarity and introduces directional order.